Okay, I guess we can start. Welcome everyone to the Guided Analytics Forecasting Platform webinar. I'm Vincenzo Tursi and I'm Partner Manager here at Knime. Today we have on our virtual stage our partner Noldus with Ram Indukuri and Shubham Goyal. Noldus offers services in the field of high-performance systems, platform strategy, data strategy and analytics, blockchain, and intelligence-driven decisioning. But before starting with the webinar and introducing to our speakers, I'd like to take care of a bit of housekeeping. So Shubham, if you can please go next.
Yeah, sure. Hi, Vincenzo. Hi, everyone. I hope you all are doing well in this difficult time of pandemic. So my name is Shubham Goyal. I'm working as a data scientist at Nordis Incorporation, and with that, I'm also a certified deep learning.ai TensorFlow developer, and interested in doing different research works. So I already have research papers at different conferences, publications, uh, and I hope you will like today's webinar, that is guided analytic platform, a forecasting platform. Yeah, thanks.
Thanks. And yeah, Ram, maybe if you would like to introduce also yourself, and then maybe we can do a bit of housekeeping as well.
Sure. Hi, everyone. Good morning, good afternoon, good evening, wherever you are. My name is Ram Indukuri. I am head of the data practice. I have kind of a unique background. I was a SAP production planning consultant. That's where I spent my early years of my career implementing manufacturing planning primarily. And then I moved into AI and big data. So I come from building and doing forecasting both on enterprise platforms as well as custom platforms. I work out of Chicago, Illinois, here in US. Back to you, Vincenzo.
Yeah, thanks. Yeah, Shubham, if you can please go to the next slide. Yeah, so before we start with the presentation, we recommend you to use the Q&A section to post your questions and upvote those that you prefer. And the session will be recorded or is recorded and will be also available on YouTube. So we'll make sure also to share this after the webinar with a follow-up email and all the links to download. And the next slide, I think it shows, yeah, where the Q&A section are placed in the Zoom application. So if you look at the bottom part of Zoom, you'll find also the Q&A button that you can click on and then write your question. And then you have also the button to upvote your favorite questions in there. So as said, we will make sure to answer those questions during the presentation or to answer them live at the end of the presentation. And with this, I would like to get back to Ram and hand over to him. Thank you again.
Thanks, Vincenzo. Shubham, if you move to the next slide. I think we already introduced ourselves. So let's move forward. So today's agenda, we're going to spend a little bit of time on Noldus, what our company is, and then we'll jump into why this solution is conceived, built in the first place, and why we chose Knime as our platform. And then we will go into the features of this platform. Shubham will take you through some of the key features, and then we will jump into the demonstration, where we actually take a sample data set in a retail scenario, and then walk you through how you could do guided analytic forecasting using Knime as the underlying platform and the workflow. move to the next slide. So this is a bit about Naldus. Our origin is basically we were providing product engineering for a lot of Silicon Valley innovative startups across the world. And we primarily come from functional and reactive programming background. Over the years, we grew. We have two major practices. One is high performance systems, and second is AI and data engineering. These are some of our key partners. Obviously, Lightbend, Knime, and Databricks are our key partners in the area of AI, and a few other big data and data partners. Go on, Shubham. So our practice areas mostly centers around enterprise data programs, artificial intelligence, and reactive products. And we are upcoming on blockchain and hyperledger practice as well. Apart from these four key practices, we have a few horizontals like reactive UI UX development, test automation, and the big one to mention is DevOps. Anybody who has implemented an AI-based system would immediately know the fun is not actually predicting, but actually operationalizing and deploying it in production. How do you manage the changing models? How do you deploy new models? How do you integrate with your target systems? Like, for example, in ERP, the forecasting need to be consumed by the demand planning modules. How do you acquire data from your source systems? How do you combine them? So we actually spend a lot of time in thinking about moving these algorithms into production, and reactive DevOps is one of our key practice that goes across these practices. Go on, Shubham. We are in four geographies. These are our key geographies. Obviously, India in New Delhi and Pune. We are in Singapore. We are in Toronto, Canada. And we are based out of Chicago, Illinois, here in US. Go on. So now let's jump into the forecasting. I'm sure all of you come from different backgrounds, have seen different forecasting systems. Probably forecasting is one of the oldest problem that we all saw. The use cases are everywhere. These are some of the use cases that we have experience with. Particularly retail forecasting is very interesting and upcoming. I would say they are industry, they're kind of leaders. Walmart, HEB, Amazon, these folks have gone far ahead of simple ARIMA, Gotch analysis or linear regression. Of course, I have to mention them as the leaders as far as we have seen. And they use forecasting to reduce the out of stock situations, optimize the inventory. Those are the two key use cases. Of course, manufacturing will be by far most widely used, industry that uses forecasting pretty widely. It is embedded into demand planning, though I would say, thanks to some of the difficulties in implementing forecasting using ERPs, I would say they are little laggards when it comes to forecasting. Utilities is investing heavily nowadays into forecasting of energy demand to reduce their outages, fulfillment, and also incentive planning. And there are, some utilities companies are doing it real time. Financial services, of course, revenue predictions, things like tax revenue planning for public sector, city planners, so on and so forth. Of course, you could use forecasting in a lot of different places, but these are primary ones that I would like to mention here. Go on, Shubham. So why do we need to build another solution on forecasting? I mean, there are plenty of them. There is SAS, all kinds of Python and R packages, SAP, Oracle, Infor. They all come with forecasting modules. So why do we need to build another forecasting platform? So if you look at the current major approaches to forecasting, obviously I have to quote the ERP, one which I have a lot of experience with. The forecasting is more geared towards collaboration, more geared towards integration. The so-called advanced planning modules, they don't look at advanced forecasting techniques rather than taking constraints into consideration. Like, for example, if you are forecasting, let's say, a production orders, demand from customers. The advanced is more geared towards, can the plan deliver? How do you adjust this plan, which is part of demand planning, but it is fed by the simple, forecasting. A lot of human intervention. Anytime you want to introduce a new data set, new information into the forecast, of course, due to complexity of ERP tools, it gets pretty complex very soon, requires programming changes, configuration changes. So as long as you stick with simple linear regression and focuses on collaboration, it's just fine to go with ERP-based forecasting tools. The second approach is, a lot of companies take forecasting out of their, ERP systems or core systems and do it offline with a mathematical approach. Of course, you could, most of you must have read, the famous book by Makridakis, happens to be, from the same school I went to. And the mathematical analysis definitely is a great way to look into trends and seasonality. But the modern, if you move to the next slide, Shubham, the modern AI-based forecasting expands on that and provides you lot richer models and ability to do predictions and forecasting. I won't go into each of the bullet point here. Of course, you will have the deck and you can go through it later. But one of the key development in the recent forecasting methods is to introduce the extraneous data sets. One of the retail customer that I have personally worked with into the forecasting has recently introduced, the weather data. And as all of you know, weather has a significant impact on some of the products that we buy. Like, for example, if it's a hot summer, the beer sales could be significantly impacted. During the pandemic, certain type of products are observed to be sold more frequently and more often, whereas the sale of value-added products have declined significantly. So people are buying more milk and bread and less of pizzas. Of course, you can add data sets that you feel could have a significant impact on your sales or whatever why that you are trying to predict. And AI-based forecasting makes it much easier and much more natural way to incorporate those data sets into the forecasting. Of course, the data pipelines may become complex. some of the models reduce the intuition. It takes a lot of experience to have build intuition into some of these complex AI algorithms. And of course, AI is compute intensive. So you may have to invest heavily into compute infrastructure. But of course, this is not an issue for most of our customers, given most of these systems run on cloud, on demand. So you don't have to necessarily, buy the compute infrastructure, forever in your data center. And of course, the skill. Go on, Shubham. Vincenzo, please keep me on time just in case if I'm taking too long. So Knime-based forecasting actually solves a lot of this problem. The problem of developing a custom AI platform for forecasting, which we have gone through multiple times repeatedly. One of the challenges, the investment required in DevOps is pretty significant. You have to do everything that you can think of when you do a traditional software application development. You need to have a CI/CD platform. You need to have a development, testing, and production environment. You need to have versioning of your data. You need to have versioning of your ML models. It is great if you could build one such thing. However, you need to be engineering. You need to be matured in an engineering way in order to accomplish all that. What we found great about Knime was all of this comes on a platform to us. We don't have to invest in multiple code management. Knime has a great way, I think, which Shubham is going to demonstrate that. You can drag and drop. You can create plugins. You can leverage the existing plugins. You can check in the code. You can version control your code. Just your entire pipeline, just like a Git check-in. So that's the beauty of why we particularly were interested in Knime for enterprises. It's very modular. The data pipelines that we have built on traditional platforms like Apache Spark, one of the challenges is to just, simple thing as what's going on. We have created a graph of how these data pipelines interlink, join, and get enriched. And they go into multiple levels, like, up to, 20 different steps with complex joins. It's actually, after a certain point, it becomes impossible to kind of understand what's going on within your pipeline. And as we develop this platform on Knime, what we observed was it is highly intuitive. You could show this to your business user and make sense out of what went wrong and what's going on within your pipeline. Third one is scalable. The beauty of Knime is one of this platform that we bring with Knime is integration with Apache Spark. Obviously, at Naldus, we are specialists in Apache Spark. We think this is probably one of the biggest plus in why you should look at Knime plus Apache Spark. We were able to achieve all the scalability that we got out of custom Spark pipelines with a simple plugin into Spark and write our the Spark joins and Spark transformations visually in the Knime pipeline. And we will demonstrate that. And fourth one is plugin based. I don't have to say that, and inbuilt collaboration. It's great developer collaboration. We extended that to make it useful for data scientists and developers and business users to collaborate together. So move on, Shubham. So I think, before we jump into the demo, these are the components of any AI-based platform. Of course, the same thing applies to forecasting. Every every forecasting will have a data pre-processing step. You need to bring all the data from your source systems into one place where you could start doing the feature engineering. Second is feature engineering, which is basically getting your data ready to be ingested into various algorithms. Third is mathematical analysis. Any data scientist before jumping in would like to do preliminary mathematical analysis, like looking at the standard deviations and imputation requirements, the cardinalities of data sets, the anomalies, the high-level trends, so on and so forth. And of course, visualizations that go with the analysis. The fifth one is actual algorithm implementations. And sixth one is once the algorithm predicts and builds a model, how do you collaborate on the results? So these are the 6 components that we are going to demonstrate today. Go on, Shubham. Same thing as a workflow. I don't need to go into the details. We will go through this in the demo. All right, with that, I'll hand over to Shubham. Over to you, Shubham.
Yeah, thank you, Ram. Thank you for a beautiful introduction about forecasting and the platform. And as you all see that we have multiple the need of this AI-based or current modern forecasting platform. What were the pitfalls in the traditional forecasting systems, the SaaS systems and other systems, as Ram mentioned, and how AI-based forecasting system can overcome those limitations. And as you also see that AI based forecasting systems also has their cons, but what we observed when we implement that with Knime, we observed that we can overcome those cons in AI forecasting forecasting based systems also. So without wasting any further time, let me move forward with the demo part. So demo will be happen in 2 parts. So first of all, I will going to show you the end-to-end flow. So I'm going to show you the end-to-end pipeline or the workflow, or you can say the application or the platform functionality that contain data inspection, data visualization, model building, forecasting solution, and the collaboration part. And the collaboration part is the most important one that a forecasting or a forecasting organization need. And then in the part 2, I'm going to show you some of the features in that particular platform. That is the scalability, the Spark plugin. I think Ram has already speak about that. Then the custom visualization that you can create with the help of Python code. Although Knime has a variety of many varieties of visualization already exist as a nodes. I will also going to show you what are nodes and how you can implement those in the Knime platform to create your workflows. Then I'm going to show you the feature that is ease of implementing new models. So right now we have created some models, but I am also going to show you how you can create even more models and compare them, like train them, test them, and evaluate them to find out which one is suitable for you or that particular task. And then the collaboration part I'm going to show you. So I think let's go to the demo now. So this is the analytic platform we are going to see, and here we create the all workflows, and this is our Knime server. So where we used to deploy the whole workflow we have created in our analytic platform. You can see that we have multiple parts, the modular parts that are data pre-processing, parameter selection, that is your forecast, feature engineering, then the visualization, the data inspection, model training, prediction view, and the collaboration part. So one of the best thing with Knime is you can every time you can see the progress. You can navigate through what the process is going on, or if you want to debug that, you can also do that. You can just see on which step you have the problem, or the step that giving you the warning. So you can also do that. I'm going to show you that also. So let's come to the Knime server now. So this is your Knime server. These are all the existing workflow you have inside your server. So right now I have signed in as a Shubham, and I can access this particular workflow which we have created for this enterprise solution. So what I need to do, I just need to click start, and okay, yeah. So what it's going to do, so basically it will going to invoke the pre-processing step of our platform. So suppose you are working for a retail, or you are creating this for a retail organization, and as you know that there are multiple data coming, like expected to come from different locations or the different stores. So the workflow we have created that takes all the data from different locations and store that in a S3 bucket, and then our Spark processing engine will fetch all the data from S3 bucket and store and nourish that, and do some transformation, and just simply store all the data into Knime data tables so that we can perform our analysis and model training part. So if I have to show you how you can track uh, the record of your execution, you need to just click on this particular job, and it's going to show you that this particular data pre-processing part is already executed, and next one is in the queue. So let me go back to the analytic, like the Knime server. So in the server, on the first web page, now your data is being loaded into Knime table. So you can just inspect your, like there are multiple things you can do on this particular page. So you can do the visual inspection, like currently we have our data like the store data, the store number, then the category of product. As you all know that in a grocery or the retail sector, we have multiple products in multiple stores. Then we have date and the total units sold on that particular date. So in this step, a data scientist can do cursory analysis of data, like the mean, the standard deviation, the kurtosis, and the missing value on every attribute. So let me show you how you can do that. Uh, you can just inspect different kind of data, like for the numerical data, if I track down it, so you can see the minimum maximum value, or the mean value, standard deviation, the variance, skewness, and also non-zero, non-missing, or the histogram that show you the frequency of that particular numerical attribute. Similarly for the other numerical attribute. And if you have any nominal attribute in your data set, uh, like we have here the class M, that is actually the class of product, or you can say the product class. So we have multiple values like 7342, 7331. You can just consider them as like the dinner and bowler, or the cheese category, or the beer and meat category. So these are different categories of our product, and it's the frequency chart on of these like these nominal values. And you can also see your data preview. So you can see that we have date column, we have units, we have store, we have the class of our product. So after doing this visual inspection, what you need to do, just click on next. And the next step, let's see what it's going to show you. So now you may have to do a sub-selection of your data. Of course, you do not want to go with the whole data. You have to filter it out. So for this particular use case, what we have created, so in this tab, a data scientist can choose which particular store he want to go with, or he want to work on the data for a particular store. And in our case, right now we are only taking a single data store uh, for the like fast processing. And but in the real life, there may be more classification and more such stuff. like maybe you have a geographical column also, maybe a particular country, maybe a particular city, and then you will go layer by layer and choose a particular store in that particular city. So let me show you the selection part. So this is going to be your second web page or second interface of this platform. So here you can choose the particular store on which you want to perform the forecasting part and the analysis part. So as I already told you, for the ease of this demo, we are only taking a subset of data, and there is only one store right now. But in the real scenarios, you will have a list of stores to choose from. So suppose I have chosen this particular store, or maybe you can say that your maybe your supply chain manager has told you, or your like retail owner told you that there is some problem going on with this particular store, and maybe with particular product that we will going to see on the next step. So suppose I'm choosing this particular store to have a deeper in like inspection about this particular store performance. And also you can see on every step the output data that you have on the current step. And that's the beauty of guided analytics. Actually, you can always see what kind of data is processing on every step, and what is the transformation like went on the previous step. So next, you have to just click on next, and it is going to give you like a more sub selection. So you can select a particular class of product, and like let's see if it executed. Yes, it got executed. So currently we have nearly 30 to 40 class of product with us. So if you click on this product list, you can see we have a lot of products here. Suppose your manager has told you that there is some problem, or you need some immediate forecasting result, or you want immediate data inspection or the performance inspection about this particular product, 7615. So you can choose that, and you can see that the current data is about the store you have selected in previous step. And now you have to click next. And on the next step, like you can also choose the date range. So maybe you want to just inspect limited time range data, maybe from 2017 to current, or 2018 to current period. So you will have that choice to make. So let's see if it get executed. So you can see now that uh, the all data is regarding only one class you have selected, that is 7615. And these are the current data you have for your inspection and further steps. So next thing what you are going to do. So a lot of you, if you have worked for the analytics or the analyst workflow or analyst task, then you need a lot of like external tools like Tableau or Power BI for creating different data dashboard, for creating different data stories, and see the inspection inside your data, and then take the decisions. But the beauty of Knime, you can create that on the web portal itself. You can create different visualization, and we will see that in the next step. But before that, we need to set some parameters for our visualization. Suppose you want what kind of distribution of sale you want to have, maybe monthly, or you want a weekly distribution. So let me choose day of the week. You want a weekly distribution. Uh, I'm just letting this date as a default for now. So I'm going to inspect the whole data that is with me, and this particular comparison plot parameters. So we have included this as in the next step. I'm going to show you. We have also implemented uh, a normal Python script visualization that show another functionality of Knime, or this particular forecasting platform, that you can create your custom script visualizations. So these labels we are going to set for those. So as you remember, I have previously selected a particular product type, that is 7615. Let's select that and select one product number one, this and this, and let's click next. So on the next step, you have the data visualization dashboard. So currently you have the filter data ready with you according to your choices. And in this particular example, we have a class attribute. We have just choose that 7615. We have date column. We have number of units sold on those particular date for that particular product class. So now data scientists can create different visualization to inspect, and we are going to demonstrate the most common ones that are using in forecasting domain. Of course, you can create a lot of other visualization. Knime basically provide you a lot of type of visualization, the JavaScript based visualization. Even you can create your custom ones. So let's see if it got executed now. Yeah. So this is your visualization and like the seasonality option selection. I'm going to talk about this later. But here you can see the time series visualization. Uh, so the first one is your scatter plot. So you can see different inspection in this scatter plot. Like you may see that for this particular product class, you have like more often higher sales on Monday on Tuesday. And if you see the bar chart also, it shows you that the Tuesday is the most profitable day for that particular store and this particular product type, and also Wednesday and Thursday. But you see that on Saturday and Sunday, the sale is a little bit low, and it do not used to happen. But maybe there may be a chance that this particular store located near to some commercial area or some institutional area where different colleges, university exist, and people used to buy those products on weekdays more than weekends. And according to that, you can take action. You can like plan your whole supply chain management or the distribution, product distribution. For this particular product, I have to distribute it according to these days more. And for Saturday, Sundays, let's not consider the higher sales and save ourselves from overstock conditions in our store. So another plot that you can create, that is your conditional box plot, and the most important one, from where the you can see on the first day you have more often higher sales than your mean sales. You can see the difference here, and also you can see that for different other days of the week. So yeah, and this is our comparison plot. So right now we have created this for every product exists in our data set, but of course you can just drag and drop some of the products you want to inspect. So let me take some of the uh, product and compare the sales of those product. So now if I go back on my plot, you can see the difference, the weekly sales difference in your different products or the product class. So that's how you can just compare your different uh, product sales like class sales. And then of course if you remember, I told you about a custom Python script you can create. So basically we have here we have just created uh, a normal like a line plot to have a comparison. But of course you can create different visualization graphs that you used to create in your data science project, like using Matplotlib, using Plotly. You can utilize Seaborn and any of the library, visualization library you used to use in your uh, Python project. So that is one of the important feature Knime has. So if I go back on my analytic platform, so I can navigate my process in this platform also. So right now I am here on this step, the time series visualization, and the report is in queued and the seasonality inspection is in queue. So that's how you can keep a look in your workflow execution, like on which step you are and what are the further steps, or if you are having any warning or any error in your Knime server, you can immediately check this analytic platform workflow and see where the problem exists. Yeah, and uh, after visualization or have an in deeper inspection uh, in your data, of course, you can create you can add a beautiful HTML, or you can create even more beautiful dashboard like Tableau and Power BI by modifying your workflow, adding some CSS, adding some HTML to this web page. And after having the visualization inspection, what you need to do, so if you have any background in forecasting, so you know that one of the key tasks to do before like feeding your data into any of the data model is to inspect the seasonality and trend inside your data, and to make your data stationary to be used by machine learning model or AI or statistical models. So in this platform, you have an option. You have to see the lag value, and like you have to see the like different seasonality parameters or stats according to the lags, number of lags, and the seasonality cutoff. So you can just mention, suppose I'm just letting it 100 by the default value, and the seasonality cutoff as zero point 0.4. And you are going to see the impact of this seasonality cutoff and maximum lag value on the very next step. So let me click on next. So yeah, so this is what I was talking about, the Python view. You can always create your Python script based visualization and leveraging libraries like matplotlib and Seaborn. So on this tab, when I just click the next, it is going to give you the seasonality checks. If you again, if you have a strong uh, time series background of, or you have worked on time series data or the forecasting problems, then you may know about ACF and PACF. So I'm not going like the deeper in ACF and PACF, but these are some of the parameter or stats we need to check, uh, or we need to evaluate our data so that we can fix those data and then feed them in our data models like AI or machine learning models. So on this step, this platform will give you all autocorrelation values which are higher than the given threshold. If you remember, uh, we have given the maximum, like the cutoff threshold and the maximum lag value. So we are going to see all the threshold or the autocorrelation values which are higher than that threshold, and its lag value. So on which lag it that like the autocorrelation value lies. So let's go on the web portal now. So yeah, you can see uh, on this tab you will have your data seasonality ACF and PACF graph. So the graph you are currently seeing is the like auto correlation factor plot that is with 95% of CI. And if you remember, we have just mentioned in the previous step the threshold correlation that was zero point 0.4. So what it is going to do, it is going to give you all the correlation which are higher than that threshold. So as you can see that the first correlation it is giving us, that is 0.483. And you can also see that in the graph that there is some correlation in your data on lag number 7. uh, Leg number 7, you have this 0.48 autocorrelation. And if you click on next, you will have the next correlation value that is on 14 lag value. So you can also see that in the graph, you have this correlation higher than zero point 0.4 on this step. And also you have a PACF plot so that you can see how much seasonality or trend, or you can basically see how much stationary your data is right now. So when you see this correlation value on the particular lag values, so you can also like to remove all the seasonality and everything. You can of course mention a threshold value to remove all the seasonality and trend from your data. So suppose I'm just mentioning the threshold 0.5 here as a threshold value to remove all the seasonality from my data and make it stationary. So if I go back uh, on my slides now, so the next step is the removing seasonality. So in the previous step, you got to know about your autocorrelation values on the different lag, and you had an option to mention a correlation threshold to remove those seasonality factors and the trend factors. So on this step, you will have your stationary data and all removed component from that seasonal data, like your residuals or your seasonality residual or your trend residual that has been removed by the platform. So let's see that on the platform itself now. So yes, you can see that these were your original signals and these are your removed trend from your data. And this is how your data looks like after removing the trend uh, or the differencing it is doing for removing the seasonality from your data. And of course, you can also see different components like the trend component or the seasonality component and the residual we have removed from the data in term of making it uh, stationary. And these are the values you have as an output after removing your seasonality from your data. So these are the residuals and these are the signals you have right now or the data. In our use case, it's like the number of units sold for that particular product. Yeah. So as we have a totally or nearly stationary data with us, now we are ready for the model training part. So what I'm going to do now, I'm just going to click on next, and let's see what we have on the next like next step. So now your data is stationary and ready for data modeling, as I already told you. Like the seasonality has been removed or the trend has been removed. So in this step, a data scientist can add different statistical and machine learning or AI models. So currently, like we have just implemented three models that are ARIMA, linear regression, random forest. So here we have used auto ARIMA so that it can automatically like take the parameters or do the hyperparameter tuning itself. As you know, if you know about the ARIMA model, we need to give an accurate AR value or I value or MA value. But this platform will take care of that automatically and do hyperparameter tuning itself. And if in case if you have your data more linear in nature, then maybe you want to go with the regression models. So we have mentioned or we have implemented linear regression model and random forest regression model. Of course, you can create a lot of other models like XGBoost or LSTM, the neural net model uh, for the forecasting purpose. So in this step, all the models will be trained and that will be saved in PMML format to be used again in a temporary file right now. But in the real scenario, you can choose if you want to save your models in S3 bucket or like any of the database. Yes. So after model training, we will going to have model evaluation. Of course, it's very important to see what kind of model is most suitable for your particular data or use case. And in this step, we are going to see different parameter values. Those are your R values, your RMSE, your MSE matrix. And we also have an option to choose the best model for our this particular product forecasting. So let me go to the web portal. Yes. So now your models are trained and we can see the different evaluation matrices and evaluation graphs uh, for our particular product or the task. So the first statistics and the evaluation you are seeing for the regression tree, that is your random forest regression tree. So you can see that these are your original signals or the original values in the light blue color, and the golden colors or the light yellow colors, those are your predictions ones. And you can see that regression model, like on a like very small scale, it can map all the spikes and the down spikes for your data. And also you can see the prediction values and the original values for this particular data on the particular dates. And also you can see different statistics like the R square value, MSE value, MAE value, or RMSE value, or the absolute percentage error. And similarly, you can see all the stats for different models. So the linear regression model we have created, you can also see some stats about that. So you can see that linear regression is mapping nearly every spike accurately. So maybe your data is linear in nature, and you can like leverage linear regression for this particular task. Similarly, you can see that for the ARIMA model, and you can choose which model is better for this particular use case. So as I told you, you can also choose which model you want to go with now. So suppose I observe that my data is, this particular data is linear in nature and my linear regression is performing well. So I choose linear regression model. Uh, the prediction date, I am like leaving it by like as default for now. And if I click next, so let's see what I am going to have on the next step. So now your model has been trained and saved. Now you can have your prediction with that chosen model. So in this step, on the previous step, I have chosen linear regression model. So in this step, you can view all the prediction values. Additionally, you will have an option to download your prediction file, and you have an option to download your model in PMML format also. So if I go on the server now, so you have all the predictions for your like this particular task or the product. Uh, it's up to you if you want to adding more columns, like maybe product class name or the product's class ID, or if you want to aggregate this prediction weekly or monthly. Maybe you want weekly like unit sold, or you want monthly unit sold. It's up to you. A little modification in the workflow can work out with that need. So I'm also going to show you that in analytic platform how you can do that. So another thing I was talking about, like you can just download your predictions. So if I click on this, you can see that it downloaded my like uh, uh, like the predictions or the forecasting values in a CSV format. Or if you want to download the model, you can see that by a single click, it is downloaded the linear regression model in a PMML format. Uh, yes. Uh, so now after you see all the predictions for your this particular task, and you have created model, you have created predictions, uh, and then maybe you click next. And on the next step, you are going to like now your forecasting data is ready, that is your date and unit total unit. Of course you can add more unit like more data columns, like maybe like the day of the week. If you want to mention according to your use case, maybe you want to mention product ID class, so you can also do that. And in this step, the forecasting data will be shared with a list of people on the email address as a Google sheet that will be shared with maybe different level of people, maybe the business owner, the supply chain manager, or retail shop owner, so that they can have a collaboration on this result or the forecasting result, so that they can choose, yes, I'm agree this much unit to be ordered or distribute in that particular store. So if we go back on the web portal, So it says that the prediction sheet sent, please check your mail. And if you click that, so you can, every person who has been listed in the platform will get a result mail as this to collaborate on that result. And when we open the sheet, uh, we have our predictions, and the date on this prediction has been created. And as a collaboration part, maybe business owners say that uh, I don't think that on this particular day this is the right result or this is the right forecasting. So he can always change the values here, or maybe other values, and he maybe say that I am done with my level of reviewing. And maybe he asks supply chain manager that I have finalized everything, and now it's your turn. Let's see, let uh, you have a look on these predictions and decide how many unit to be distributed to that retail store. So this type of collaboration you can do with this platform. So after rectifying all the different rectifying the prediction values by different layer of people, the original prediction values and modifying values will be sent back to the data scientist for the future model predictions improvement, so that he can maybe apply different more models, or he maybe apply different other parameter tuning, or he maybe go with different models like LSTM or a different statistical model for this particular product. So this kind of feedback will be sent back to the data engineer and data scientist for future improvements. So this is the part of the demo, and after that you can always discard your particular job if you're done with your task. Uh, yeah, so this was all for the application of the platform demonstration. And you can see that this job has been discarded now. And let me show you all the components that I was talking about as a part 2 of this demo. So you can see that in data pre-processing, as I told you in the presentation, we have implemented whole Spark application to load the data from different store. Currently, we are storing all the store data into S3 bucket. And you may you can leverage more Spark operation to create this whole workflow. And another thing I want to show you that you can always create different custom visualization. So you can see that I'm leveraging here the default or the already created visualizations by Knime software. And also, if I found that I need to implement more other visualization, you can always leverage Python script for that to create your best visualization graph. And the last thing I want to show you that the model training part. So as we saw in the demonstration, we have created 3 different model like the random forest, linear regression, ARIMA model. Uh, but you can create as much as model you want to create. You have to just search for the particular node here. Maybe you want to create the boosting algorithm, or the boosting like the regression one. So you can just do that in a drag and drop manner. I think Ram has already talked about the benefit of Knime software or the Knime platform, that you can always implement in a quickly any a new feature in your workflow or in our platform. So that's how you can implement more and more models for your this platform or your use case. So yeah, let me delete this one. Yeah. So this was the demo part, and as you saw that the different benefit of using this platform, that is a collaboration not only between a data engineer, data scientist, the data engineer who are creating the Spark application, and the data scientists who are actually creating the visualization graphs and model the model training part, but also the collaboration between the technical person and the business persons, so that they can rectify all the values that are predicted by different models, so that you will have an accurate idea of your supply chain management, or your like the supply management for any of the domain, maybe in this case for the retail one, maybe for the manufacturing one where you need different like the products or different small tools for your uh, like the machineries. Yes. So this is all for the demo part. This is how the application work. Hope you like it. uh, let's move for the uh, presentation mode now. Yeah. I think now the Q&A part. Maybe Ram, you can choose the questions to be answered.
Sure, sure. I think the first question is this only available in Knime server web portal? Um, Shubham, can you take this?
Yeah. So yes, so this particular platform or solution we have created on Nine Software. So the workflow we used to create in the analytic platform, as we already saw this platform, we have created the whole workflow. Uh, Always we need to deploy that on Nine server. Uh, mm, and the Knime server, yes, and then leverage the web portal functionalities. So yes, it's available on Knime server web portal to be used.
Just to add to that, I think if the intention is, can we run without the web portal? There are certain plugins that we have used, especially the Spark plugin, which is available in Enterprise Edition. So yes, this requires enterprise version of Knime. The next question, typically who is the buyer sponsor in the client organization, data science leader, IT, or business side? We actually saw different organizations work differently. Those who have mature data science organizations usually lead with the data science team. Like for example, the retail customers, they have a separate enterprise data science group. They typically tend to evaluate such solutions and platforms. However, I have also experienced where business has led this discussion with IT, where there is no matured data science team or a centralized data science team taking responsibility. I think Knime platform particularly is a very good fit there as well, where business recognizes there is a challenge. Say for example, I'm using SAP. I'm into pandemic situation, and the traditional forecasting is not going to work. I need to quickly develop something that gives me a better forecast, which I would import back into my ERP, and do my demand planning. I think in those situations, business will lead this discussion with the support of IT. So that's the second scenario. Hope that answers the question. Next question. You mentioned you are able to version control your workflows. How do you manage that? Shubham, you want to take this one? How do you version control your workflow?
Yes, Ram. So basically, there is a functionality in your like the web portal administration. So uh, if you want to leverage the Git, you can also use that. Like there are multiple like nodes for the Git version controlling directly from Knime Analytic platform. So whenever you will create a different workflow, you can versionize that. Or maybe if you want to do that manually, you can also do that by mentioning different versions of your like the workflow. So there are two options. You can leverage the Git functionality provided by Knime itself, or you can manually do that.
Just to add to that, we clearly see an opportunity to use something like CI/CD tool like Jenkins, where you develop something on your branch and run the job, and it has access to move that into a common and production environment. But in this case, what Shubham has showed is simple Knime standard, whatever comes with the Knime. Next question is, have your model ever been used in transfer pricing, intercompany price setting? Can you share some insights into where AI was helping the transfer pricing? The straight answer, we haven't used this model specifically in a transfer for a specific transfer pricing setting, but I can see multiple ways it can help transfer pricing. Not only this pipeline, in general, AI. So when it comes to transfer pricing, usually companies set it in a couple of ways. Either it is cost plus transfer pricing or market-based transfer pricing. And obviously, transfer pricing has a large impact on financials and your tax. Usually tax is the main driver that decides what your transfer pricing is going to be. But if you choose, let's say, a market-based pricing, and you want to forecast your risk of overall financials because of setting the transfer pricing based on market. So predicting the market price and calculating the impact of that price on your financials is obviously a great fit. So you could potentially forecast your product's market price, and then come out with a mathematical approach to see what the impact is going to be over next months or years on your selling units profitability versus buying units profitability versus an organization level overall impact. If you are doing cost plus, there are a couple of things usually companies will take into consideration. Obviously, if it is across two different countries, then there is a currency risk. Even within the same country, there is a bankruptcy risk. So there are various risks that are involved in a company, setting the transfer price. And obviously, forecasting is a great way to, predict the currency value, risk of bankruptcy, and any extraneous influences that could impact your transfer price. So the key point here is there is a great value in having the infrastructure and a malleable, flexible, and quick way to calculate and forecast these values that can be applied to transfer pricing or any similar use cases. Hope that helps. Next question is, by what percentage can Knime reduce the time to develop AI applications compared to the Python or coding approach? Go ahead, Shubham.
Yes.
I think you have actual experience in developing pipelines both ways, so go ahead.
Right. So basically, what I observed is to develop an whole AI application pipeline in Python and R, it take a lot of time to create. Like you have to create different modules, you have to create uh, different feature files, and you have to also take care of the modularity so that you know which part is responsible for which particular which particular the functionality. And with the Knime, you can just if you have to just do simple operations like the transformation, or you want to create a simple linear regression model, or many other models also, you can just use a drag and drop functionality to create those. So it's like in the percentage, I can say it will reduce the time by nearly 60 to 70% in the development. Even when you have to create a new features, or you even if you want to retrain your model, that will also just you have to modify few values inside 9 nodes only, and then you can just uh, execute that particular thing. And of course, uh, in creation of AI application with Python R, you also have to take care about CI/CD pipelines so that all the changes can be easily transformed from your research environment to your development environment, and your then to your production environment. And some of the key features that should be have, like reproducibility among all the different environments, should be there. So in the Knime, you do not have those kind of difficulties. You do not have to take care about your CI/CD development. On a one click, you can deploy your whole workflow. So yes, this is the uh, kind of reduction time uh, that Knime saves for you. Hope this helps.
Thanks, Shubham. Another question, Parquet to Spark. Can you read multiple Parquet files? Parquet Reader node does not do that. Um, Shubham, should I take it?
Yes, you can.
Uh, Absolutely, yes. I am not able to recall particularly which way we did. I don't know. We can go into the technical details, but in this demo, we did read multiple files. In fact, you could read from multiple buckets, S3 buckets, and uh, multiple folders as well. I mean, Knime and the plugin and the flexibility to do additional customized code will allow you to accomplish this. But Shubham, unless you specifically know if the Parquet Reader node, how did we do? Um, uh, the short answer is yes, you can read multiple Parquet files. I don't know exactly how it is done technically, but it is demonstrated that we read multiple files.
Yes, Ram. So I think we write multiple files with the Parquet reader itself. We just fetch out everything from S3 bucket, all the Parquet files, and just read them. Uh, uh, I also not able to recall uh, if we use a single of course we use a single Parquet reader, but how exactly we did that.
Yeah. I think what we did was, the Spark plugin actually is capable of reading the multiple files.
Right.
Maybe Nitin, feel free to touch base with us. We could share, more details around, how this can be done.
Right.
I think one last question: why were the predicted values in your demo always absolutely smaller than the observations? Good question. Shubham, do you want to? Um,
Yes.
to take
So
this?
basically, the model we have created that was only for the demo purpose. So maybe it's not that much accurate right now. Maybe the threshold value we need to change the threshold value, or maybe the seasonality inspection we have to do again and see what is the threshold if we can change that, or we can use any other model for this, the state-of-art models that are XGBoost or different bagging boosting algorithms, or maybe neural net model for this particular use case. So these models are the most simplest one we took only for the demonstration part. uh, I'm not saying these are very accurate right now, but always you can choose. You can have different experiment on data science workflow, and that's how data science pipelines used to be created. You have a research environment, and then only you go in the development environment and the production environment. So first of all, you need to do a lot of research, what your data is, what type of data you have, and what algorithm is most suitable for you. So here we just created three algorithms. Maybe you can create six algorithm, the LSTM one, or the XGBoost, or maybe other boosting algorithm for that. But yeah, that wasn't good question. Like uh, maybe the first values are lower, and we only see first 15 values in the first go, or on the web page. uh, in the next next 15, maybe they are like the exactly same or the higher than the observed one. uh, yeah,
Very,
the
very
answer
good
is like,
question. Yeah, very good question. Um, the the beauty of the platform is it literally takes maybe an hour to plug in a new model. Of course, the actual tuning of the hyperparameters. What's the best fit. There is obviously a lot of groundwork, but once you have the pipeline, ingesting the data, building a new model, especially those who are already available online, is pretty easy, and this can be tuned further. That was, pretty good bunch of questions covering a wide range. Appreciate your active participation. Um, Over to you, Vincenzo. I think we don't have any more questions.
Yep. Thank you very much, Raman and Shubham, for the great webinar. And thank you everyone also for attending the webinar. We will make sure to send you a follow-up email with a link to the registration of the webinar and also the slides that have been presented. Thank you again and have a great day.
thanks everyone.
Thanks, everyone.